students, today we are going to see the problems in unit number 5. The first problem is you have to construct a state model for a system characterized by the differential equation, and you also give the block diagram representation, right? So now while you are solving the state model based problem, first you have to determine the number of state variable, right? So what is the meaning of state variable? That is very easy, right? So the number of state variable is nothing but what is the order of the equation? The order of the equation is 3, so the number of state variable is equal to 3. And next you have to determine which variable you can keep it as the state variable. That is what here the number of state variables are 3, and among the variable y and u, which variable you can keep it as the state variable, right? Since the given equation involves with third degree polynomial of y, let me consider the state variable as y and their derivative, right? So the state variable as y and their derivative. What is the meaning of derivatives? I hope you know. So what is the meaning of derivative? If y is there, what is the derivative? If y is there, what is the derivative of y? That is dy by dt is the first order derivative. What is the derivative of dy by dt? That is d square y by dt square. What is the third derivative of this? This is d cube y divided by dt cube. I hope you know what I am trying to say, right? So now this y will always represented by y, but here dy by dt here will be represented by y dash. That means y dash is represented by y over this dot, and here this is represented by y double dot because it is involved with 2 time differentiation of y, and this we can represent it as y triple dot. So these things you have to remember, right? So now we are going to keep y and their derivative as state variable, right? So this is the first step of any problem. You have to keep this as the step number 1, right? So now we will go for step number 2, right? So step number 2, you have to allocate the state variable to each equation, right? So that means here I am going to keep the state variable as x1, x2 and x3, right? So which one I can take it as? So you can write down y as x1 and dy by dt as x2, that is derivative 1, and the second derivative d square y divided by dt square, that is the x3, right? Can I call it like this? x1 equal to y, x2 equal to dy by dt, right? So here let me call it as x2 equal to dy by dt. Why don't we call it this as, I have already told you dy by dt is nothing but y dash. I can keep it as y dash. Since y equal to x1, you can put it as x1 dash also, right? So from this we can conclude that what is the conclusion we can make? We can conclude it like x2 is simply equal to x1 dash, right? So this is the first equation, right? Similarly x3. Now tell me what is x3? Since x3 equal to d square y by dt square, this one you can call it as y double dash. Yes, obviously y double dash. Or otherwise you can call it as, since this is the first derivative of x2, I can call it as this as x2 dash. Very good, right? So now what is the conclusion we are making from here? What is the conclusion we are making it from here? x3 equal to x2 dash. So this is the conclusion we are making, right? And these are all the state variable assumption. Now if it is like this, let me choose, let me find out, or let me choose d cube y divided by dt cube. Any idea about what is the value that I can assign for d cube y divided by dt cube? See, here x2 equal to dy by dt, that I am assigning it as x1 dash. Here x3 equal to d square y by dt square, that I am assigning it as x2 dash. Similarly, d cube y by dt cube is the derivative of which one? x3. So I can assign d cube y divided by dt cube as x3 dash. So this is what we are going to choose it as. So d cube y divided by dt cube as x3 dash, right? So now we have this equation, and this equation. All this equation you try to put it over to the given differential equation. What is the given differential equation? This one, right? So this is what our given differential equation, right? So what is this? d cube y divided by dt cube, right? So d cube y divided by dt cube, right? So now let me copy it so that it is easy. Copy. Okay, so now this is the given differential equation, right? So now in this given equation, let me put down d cube y divided by dt cube as x3 dash. So I can put this as x3 dash plus 6 d square y by dt square. What is the value I have assigned? D square y by dt square. Either we can assign x2 dash or we can assign the state variable called x3. Now keep in your mind, I am going to represent the x3 dash in terms of the state variable. What is state variable? What is state variable? Yes, the state variables are nothing but x1, x2 and x3. So these are all the state variable, right? So x3 dash plus x6, x3 plus 11. What is dy by dt? What is the equivalent state variable for dy by dt? Yes, x2. So I can put it as x2 and plus 6. What is the state variable assigned for y? Yes, that is x1 plus u equal to 0, right? So now this is what the equation for the d cube y for the given differential equation. So let me make it out. X3 dash equal to, let me take everything into the opposite way. So x3 dash equal to minus 6 x1 minus 11 x2 minus 6 x3. So let me put it in the x1, x2, x3 order followed by the variable u, right? So not plus u, minus u, alright? So you have to put minus u, right? So this is the equivalent equation for this one, right? So now what I have to do? Here we have the equation. This is equation number 1, right? So this is the equation number 1 and this is equation number 2 and this is equation number 3. Now we have the derivative of equation, right? So equation 1, equation 2 and equation 3. Now what I will try to do? Yes, what I will try to do? Now we have to put each equation into a matrix format. What is the first equation? x1 dash equal to x2. What is the second equation? Equation number 2. x2 dash equal to yes x3. Similarly, x3 dash equal to this one minus 6x1 minus 11x2 minus 6x3 minus u. So these are all 3 different equations. Now we have to put this equation into a matrix format. Why? Because we are all aware about any state model can be represented by 2 equations. What is the 2 equation? Very easy. One is called, and you know what is output equation. State equation is x dash equal to ax plus bu, where a equal to system matrix and b is equal to input matrix, and y equal to cx plus du, where c equal to output matrix and d equal to transmission matrix. Those things you may know already, right? But this equation is enough. No need to remember about the size of a, b, c, d and all, right? So we can put that equation into the, first we will put the equation into the state equation format, right? So now I will put it into the state equation format. What is state equation? Yes. So what is this? x1 dash, right? So let me change the color so that it is, right? So what is the equation? x1 dash, x2 dash, right? x3 dash, right? So now this is equation. So now I am putting everything into a vector, right? So now we have some value, that is a, and some value here we are available, that is x. We know what is, how many number of state variables we have assumed? x1, x2 and x3. So those things I am putting over here. Because this is ax plus bu, right? So now this plus, what is the value you have to write down? ax plus bu, right? So for b, you have to write down, you have to give some space for b. So let me leave some space. And since the u is a single dimension matrix over here, so let me put down u like this, right? So now we have to put the given value into the equation, right? So what is x1 dash? X1 dash equal to x2. So that means I can put it as x1 dash as 0x1 plus 1x2, right? So let me change the color, right? So 0x1 plus 1x2 plus 0x3. I can put plus, how many number of times u is there? How many u is there? S. How many u's? There is no u, right? So that means 0 times. So I will come later, don't worry, right? So now, what is x2 dash? X2 dash equal to x3. That means 0x1, 0x2, 1x3. What about x3 dash? That is minus 6x1, minus 11x2, minus 6x3, right? And here in x1 dash and x2 dash, there is no variable is involved for u. So I can put it as B matrix as 0 for x1 dash, 0 for x2 dash. But I am going to put minus 1 for x3 dash. Why? Because that here we have the symbol called minus u, right? So this is what the state equation for the given differential equation, right? So this is one thing. Now let me write down the another thing, right? So let me write down the, what is this? Output equation. Any idea about what could be the output equation? Yes, since y is a single dimension, let me put down like this, y equal to cx. Since there is no value of maximum d value is not involved, so y equal to cx. So for c, see here x is nothing but the single dimension, it's a vector like x1, x2 and x3. Since it is a 3 cross 1 matrix and this y is a 1 cross 1 matrix. If you want to get this matrix to be 1 cross 1, any idea about what could be the size of this particular matrix C? I am going to write it over here. Yes, any idea what should be the size of C? Yes guys, obviously, right? So what is the value? That is 1 cross 3, right? So that is why 1 cross 3 into 3 cross 1 will be 1 cross 1. So what is the value? 1 cross y equal to cx. So what is the value here? Y. So here tell me what is the value of y. Here what is the value you have assumed for y? Simple. Y equal to what? X1. So simply y equal to x1. So in the place of x1, y equal to x1. So 1 into x1, 0 x2 and 0 x3. So this is what the output equation, right? So this is how you have to write down the state equation and output equation, right? Okay, fine. So now with this the problem is over? No. See, we have to give the block diagram representation also, right? So in order to give the block diagram representation, that is very easy. Okay, so now we'll move on to the next section called block diagram representation. Remember guys, this problem is very important. So block diagram representation, right? So we'll go for it. Okay, so this is very easy. So you have to proceed as whatever I am going to tell it. Okay, so now let me take it as the first variable. Okay, so let me take it as x3 dash first. So x3 dash is there. If I am putting that variable, okay, let me change the color. So if I am putting x3 dash over a block called integrator, what should be the output? Any idea? X3 dash is the differentiation of x3. If I am putting that over the integrator, what is the output? Yes, obvious. Both differentiation and integration gets cancelled. What is the output? That is x3. So now as per our state variable assumption, what is the variable x3? Yes, x3 equal to what? x2 dash. So x3 equal to x2 dash. So now x2 dash. So now we have x2 dash. If I am putting x2 dash over a integrator, what should be the output? Yes, the output is x2. So what is the assumption we are making for x2? Yes, x2 equal to what? x1 dash. So x2 equal to what? x1 dash. Now we'll try to pass x1 dash into a integrator. So integrator, if you are passing it, then x1, right? So this is what the value x1, right? So that x1 is nothing but our state variable y, right? So now this is what we have to put it first, right? So now after that we have to consider the equation. Now what is the equation? x3 dash equal to minus 6x1 minus 11x2 minus 6x3, right? So what you have to do, you have to take a lead, or you have to take a lead over x1, you have to take a lead over x1, and you have to take a lead over x2, and you have to take a lead over x3, and you will try to multiply the values, right? So what is the value you have to multiply over x1? Which value you have to multiply? Minus 6. And what is the value you will multiply by x2? Yes, look at and tell me. Minus 6 x1 minus 11 x2, right? So minus 11 you have to multiply. And which value you have to multiply here? Yes, minus 6 x3, because here we have minus 6 x3. Right, whatever that you have to do, you have to add all these values, minus 6 x1 minus. So in order to do the addition, which symbol you will use? Yes, which symbol you will use usually? Which symbol you will use? Yes, I want the answer from you guys. Yes, which symbol you will use? Which symbol? Yes, so we will put a adder, right? So we will put adder. So we are adding both the inputs coming from this way, and whatever the value is coming over here, so this value is again added with one more adder. So one more adder, let me put it down. So this adder also, what is the value here? Here we have plus, here also we have plus. Now this is what the value. Now this value, is that over? x3 dash is over? No, still we have one more variable. What is the variable? U. So minus u is also must be added with the remaining value. So what you will do? So use the, this value u must be multiplied by minus 1. So what is the resultant? Minus u is the resultant. Now what you will do? You will try to put a multiplier. That multiplier will multiply this signal over the previous signal, this one, right? So both the signals are multiplied and we are getting x3, right? So this is how you will be drawing. Now we can see that x3 equal to minus 6x1 minus 11x2 minus 6x3 minus u, and x2 dash equal to x3, x1 dash equal to x2, and the output value equal to x1. This is what the equivalent block diagram representation for the given differential equation, right? So thank you guys.